Anyway, then today is some introduction regarding actuator, and especially we work on DC motor for today. Next lecture we work on servo motor, and after that we work on stepper motor. These three type of the actuator I will teach you, and even as I gather the data and put them in PPT, I think now it's one of the nice PPT that I made. I wish that you also today enjoy the lecture and learn more. Also, the task 12 was good. And now I think most of you learn so many things from Arduino. I'm happy, but please continue to do the task. Still, I think some tasks remain of up to exam. We have some tasks, and we have one compact task which I will tell you at the end. You will do that and submit it me as the midterm exam. This part of task also is one part of your midterm exam, and then we go for the final exam as per as school decide and what school tell us to do regarding this online course. Anyway, first of all, let us see what is actuator. Actuator is one of the famous components in mechatronic and control system, and are device that accept a control command and produce change in physical system by generating the source, motion, heat flow, and etc. This device can make something to move, and normally actuator used in conjunction with power supply and coupling mechanism. The power units that we can have for these components can be AC or can be DC at the rated voltage and current, and coupling mechanism act as the interface between the actuator and physical system. Typical mechanism can include the rack, pinion, gear drive, belt drive, lead screw, and nut and piston and leakage. Okay, initially today I'm going to give you some general information regarding the actuator, which some of you may don't know, and but some of you may work with that. It's no problem. But these are very brief. That if we want to work, it's better that we have this idea and these data regarding the actuator. As I say, these divides turn the energy. Typically, it's electrical, and as the output, it can give the motion. We have some features for that, something like speed, force, torque, power, and efficiency, which we should work on them. Um, okay. Uh, as the total definition regarding the actuator, I can say that actuator are the device which use to converting the hydraulic pneumatic means that working with air or working based on water or electrical energy into mechanical one. The mechanical energy used to get the works done, and actuator perform the function just opposite to that of the pump. They can be used for lifting, tilting, climbing, opening, closing, mixing, the turning, and many other operations. This is the definition of the actuator which we can part. But which type of actuator we have? We can have five category of electrical, electromechanical, electromagnetic, hydraulic, and pneumatic one, which we just working on electrical part in this lecture. And electrical one can be DC motor, AC motor, and stepper motor. And also we can have the switching device, something like mechanical switch, like solenoidal relays, and solid state one, something like diode, thyristor, and transistor. Something that Now I will give you, these are some regarding some mechanical engineering part and electronical engineering part, but soon we are going for the programming part of them. As here I shows, the electrical motors can be DC motors or DC servo motors, AC motors, and stepper motors, and solenoid. Mainly we work for first one, the electrical actuator, and we will have them for up to end of this week. For hydraulic actuator, which you use the hydraulic fluids to amplify the control command signal, we will not work. And pneumatic actuator also, which they use the air as the driving force, we will not work. But if you learn the solenoid or relay part, you can work with them very nice, and there is no problem to control them. Then that is why we just focus for first part, I mean the electrical actuator part. Let us see which motors we will cover. By the face of them or shape of them, you will see here that we have three type of the motors: DC motor, servo motor, and stepper motor, which I'm going to teach you up to end of this week. And you can make your robot, you can make any movable system with these actuator parts. As a brief, if I want to tell you, the DC motor, which is uh, consists of two magnet and one coil, means the number of coils which they are turning inside of these magnet, and they have the force which calculated by current multiplied by length of the coil, and the force which will be come to that magnetic force to that. And due to the electrical current in a wire inside, a magnetic field will generate and move this coil for us. Then proportional to the current can be controlled by some potentiometer. And there is one problem with DC motor, which is it's very hard to control them precisely. I mean, if I want to rotate 2 degree or 3 degree or 4 degree, it's very difficult. But if I want to have the continuous movement, the DC motor is the best option. I think for this part, we will come back to see it once more. As a brief, a DC servo motor is combine DC motors with some control circuit, which can have and control by PWM through the control pin. And then with the pulse that you will generate, you can have the accurate degree. Okay, but still we have some limitation regarding this degree generation, and we should think how to control it better. The third part of the motor, which is the stepper motor, which can control the series of by the series of electromagnetic coils, and center of shaft has the series of magnets which mounted on that. The coil or alternative give the current or not and create the magnetic field which repulse or attract the magnets on the shaft, causing the motor to rotate. This is the principle of this motor, which allows for very precise control of motor. Uh, it can be turned in a very accurate step, in a very accurate and very steps to set the degrees increment. We have two base on this stepper motor, which we call it unipolar and bipolar, which we will talk on the specific lecture that I prepare for you to discuss how to control and run this motor. Okay, um, now we will start to run some DC motors as the target of today's lecture, and then slowly we have some example. For today's lecture, I prepare 7 examples for you that you should do it as task number 30 and send it from me. It's very nice and you will learn it. The first one is that simple on and off or wind controlling the fan. As you will see here, this program it's very similar to LED blinking on and off. Means that um, how we can control the uh, uh, DC motor uh, with on and off, and then put some delay for that. Um, just for 2-3 minutes, see this program. Then uh, we should work on that, and then see that how to control the motors better. As you can see this example, what we have done at the first step, we say that what is the pin mode? It means that it shows with we define which pin is output, which pin is input, and just as I show here, I specify the pin number 13 as the output and connect it to the motor. Means that the pulse to control the motors or turn it on and off will go through this pin number 30. As you learn, any pin we can use, 0 to 13, okay? And then in the loop part, just I make it high and low. What it will do, it will just turn on and off the motors for sometimes, but what is that? It's not the real control for our motors. There is two problems here. One is that it can turn on and off the motors, but it cannot turn on off all the motors. It's related to the working voltage and also the current which our motors need. As I use the small fan here, a small fan needs less than 200 milliampere. Then I can run directly with Arduino. But for the motors which they are using the high current, what should I do? That is the question. Next example. What I will do, again, we will turn it on and off. But if I change the high and low pulse here, you will see that I can go to the uh, um, clockwise movement or anti-clockwise movement. Means that I can rotate to right or I can rotate to left, okay, with 2 pin, okay. Uh, First pin is that if I want to code for rotation with just on and off, I can do that. If I want to go for clockwise and counterclockwise rotation, here I can use 2 pin of high and low, and just I should reverse the polarity of them. Means that instead of having the fixed ground to my DC motors, I should use 2 pins of my DC motor to pin number 13 and 12. And then by changing the high and low of them, then the direction of the motor will be changed. And as you see, I put some delay between them. Still, these 2 examples are not good to drive and run a DC motor. They are not in the proper method because they can kill your Arduino board. I mean that if you want to follow these 2 examples to drive the DC motor, you will not be successful to run it. But what we should do? This is the question. And how we should control the DC motors in the proper methods. This is the key. Generally, due to the voltage, due to the current, and working condition of our motors, we should select the proper intermediate device, which we call it drive. And for DC motor, they made lots of ICs and even modules that simply you can connect to your DC motor and just give it the pulse 5 and 0. Then your motors can act perfect and it can run proper. Okay, keep it in your mind that having this drive will have the safety for your Arduino board, as well as can help you to have the more precise control to your motor. I will tell you these two DC drive here. For the stepper motors also, we will use the first one, means L298 as the good driver, which it's more demand between the people who will make the robots or who will run any other uh, uh, working with the motors. Anyway, let us see and have some information from first driver L293 or 293, which this chipset is the 6-pin motor driver RC and mainly used for drive the motors. Even I can tell you that sometimes this driver will use for other applications, but mainly they will use to control by the motors, and it's capable to running two DC motor at the same time. It's very nice that you can run the DC motor based on that, and then it can run your DC motor up to 36 volt. Okay, but your current should be less than 600 milliampere and can control it with any microcontroller like ARM, like Peach, like Arduino, and ICs is like this. Let us see much more. Um, if I want to tell you the background of this DC drive, this type of drive, they will call it half H bridge. H-bridge are type of the driver which can use to run the motors in both direction. Means that clockwise and anti-clockwise direction. Then it's very nice. You can just connect your motor to this, give the proper pulse, and your motor can move in clockwise and anti-clockwise. Or if I put it on the robots, it can go straight or can come back. Okay. This IC is running two motors, very important, at any direction at the same time. And circuits in protues is something like that. Let us see what we have. If you see, I have IN1, IN2, and EN1. And also I have second channel. EN1 is enabling pin, which will something like switch to the IC. It will make it on or off. And generally, we will connect these to 5 volt and always it's enabled. Then which pin remain? We have IN1 and IN2, IN3 and IN4, which as we know, IN1 and IN2 is related to motor number 1. IN3 and IN4 will related to motor number 2. Let's go more. All the ground pins from motors or for the drives should connect together. And there are two power pin, as you will see, VS and VSS. VS is the voltage which we are using to run our motors. And based on a specification of your motor, you can select it between 4.5 volt to 36 volt. Here just I'm connected to 12 volt. Okay. Enable pin, I mean pin number 1 and 2 and 3 and 4 are used to enable the input pins for motor 1 and motor 2 respectively, since in most case we will be using both motor uh, Both the pins are held high by defaulting the connection to the 5-volt supply, and the input pin 1 and 2 are used to control motor 1, and 3 and 4 will use for motor 2. The input pin are connected to any digital circuits or microcontroller to control the speed and direction of the motor, and you can even toggle the input pin based on the some following table which I will teach you here. It's very nice. You have in 1 and in 2 for each motor. Means that if you put in 1 low and in 2 high, it will go to direction 1. Means that it's going to clockwise. If you reverse it, make it high and low, it's going to reverse direction of 1. If you put both of them high or both of them low, then it will be a stop. Then if I want to run my motors, just I should connect these two pins and give one pin high, one pin low. And for any stop, just I need low, low or high, high for these two pins. Same thing I can do for motor number 2, means that same table I can have. Okay, we learned the driver. Now we should connect it to the Arduino. As we say here, we just need just two pin, IN1 and IN2. If I want to run the driver here, just two pin is enough for me. I made one even a little bit much more complicated design here, which I'm going to generate the PWM pin on pin number 9 and 10, and then they have the various speed of my controller. Let us see my program here. It's I combine it with the key, and whenever I will press the key, then it will go and generate the PWM through pin number 9 and 10, and then by and related to that numbers which is generated, it will work. Okay, I think let us see how we can do this simulation inside of the protues that I made for you here. First, you can open the project, and then based on the project, I think this part most of you not, should know. You will select the default page, and then just finished. Then your blank page will create through the library. Just you should go and search the driver name L293D, and then after that, okay, insert it inside of your page. After that, we need one motor. We will put the motor. Simply you can get it, and then some voltage reference we need. That again you can insert it inside of your library. Now start to do it. First we'll put the driver, then I need the motors. I should go to select the motor and connect it to out number 1 and 2. Meanwhile, it's better that I connect the VCC voltage together, means that 6 and 40 generally will make it up to 5 or 12. Okay, I will put the label here to make it better. And this ground also should connect together. After connecting them, I'm going to connect the ground. Yes, I put the ground like this together. And then after that, I should target for controlling pin. First, I connect the enables and connect to the VSS. Then let us see as the next, I'm going to connect the motors. Just for two motors, I will put for input 1 and input 2. Okay. Just connect the polarity like this. Very simple. Going there. Okay, done. Then next part, I need to have the control for IN1 and IN2. Initially, for first simulation, I didn't use the Arduino or any other microcontroller. Just I try to give the command based on fixed voltage to understand the performance of the room. Okay, now I will run it. Yes. First, all are zero, it's a stop. Just I will take 1 and 0 to 1 in it, then you will see that they are going supposed to the clockwise. If I change this, it's go to anti-clockwise. This simulation aim was just you to learn how that table works. You will see that if I put 1 1 or 0 0 to any pins, it will stops and it will not move. First, understand this part. Okay, that was the first thing. Now let us see if I want to connect it to the uh, mm, Arduino. How should I do? You know that here we use the pin number 5 and 6, which connect to the left motor. Pin number 9 and 10, I will connect to the right motor. And we are selecting or enabling the PWM for the motor connection, which those pins are indicated by the wave sign in the Arduino. Okay, means that the PWM pins are specified by this symbol on the Arduino, and you can see pin number 5, 6, 9, 10 are some of such pin can make the PWM for us. Enable 1 and enable 2 are connected to with pin number 12 and 30, or they can directly to VCC. I want to have the control for them, and always we will keep these two pins as high or 5 volt. Uh, the next thing is that to control the speed, it's essential to keep those pin high, and VS and VSS are connected to 5 volt fixed supply, and ground pins are connected together. The next thing that I can tell you regarding is that we learn how to do these. First, we will use the Arduino Uno or Mega, and I use Mega here. You can use Uno, there is no problem. I put it here. After that, I just zoom it. Okay. As the PWM pin are specified here, you can see that from palette, we will find the driver L293D, put it near the Arduino. Then we need some motor. Just select the name of motor, but remember that whatever components that you want to take, try to take the active one. Okay, take the active one. Next job is just to connect pin number 3 and 6 of controller, two motors, and pin number 5 and 6 of Arduino to the driver, and respectively the other PWM like 9 and 10 we can connect to pin number. Okay, let me see. Yes, I will connect it like this. Okay. Pin number 11 I put for enable 1, and pin number 12 I put for enable 2. Even I can put it directly to the VCC, there is no problem. Okay. Next part is adding the motor, just the right one, suppose to channel number 1, then left one to channel number 2. Let us do this. Okay. And the next is ground and VCC. For ground and VCC, for VCC, we can use this item also. Yes. And for the ground one, simply we can connect these two ground pin together, and then yes, here, this one. Let me connect it better. Okay. It's better that I put this VCC up, then yes, the connection will be better. Now now half of the job is done. Just I will set the voltage or input voltage here, and some part number like this I will put. You can put or you can. That's better that if you can put it there. This voltage is 5 volt, as you will see, and my motor also working based on 5 volt. Then here I rewritten the program with the same speed as usual, and first comment of this video, we have done it. Then okay, run the Arduino. Then we will start to analyze the program. First, as you will see, we specify the pins, means enable pin, pin number 5, 6, 9, all of them as the inputs. And then let me save it. Yes. And then we define some function with some PWM speed, and then run it inside our Arduino board. Then it should work. Let us see. Let me load on inside the board. Let me go a little bit fast for the code part. Yes. If we upload, you will see that the motors will go right and left. But there is something regarding the PWM which we will talk more now. If we want to go with the high speed, we should just change the PWM which we will generate inside of the code. If you change this ratio, then it will come up and it will, speed should change. Let us see. Yes, you will see that the speed is changed here. Okay, let us see more practical things. We want to do this job in the real environment, moving two motors. Then this is some project of Arduino. What we need one Ono, one L293D, two DC motors, one breadboard and some wire like this, and some battery. The connection is very simple. First, we need the VCC and ground, which we will connect to the breadboard. Okay, and then we need VCC of ground of the IC, which is because it's a running voltage for the motors. We use the battery for that. We give the VCC and ground. Ground are connect together. Then first pin of the motor and second pin of the motor, enable 1 and enable 2. Same enable 3 and enable 4 will connect to the driver as per as the diagram here. Then we need the controlling pin, which we are going to connect to int 1 and int 2. Yes. And two more pin we need for motor number 2. Now, that was the diagram by software. How it can be in real hardware, it's here. I'll try to show you with this clip that this is the driver and Ono board. First, we will connect the VCC and ground of the Arduino board. Then we'll try to do it as per as the previous diagram that we had. It's better that you use two color, which will help you to understand which part is ground, which part is VCC. Then VCC of the IC I will connect. And then ground of the IC again I will connect here, which we know based on the driver. Then IN1, IN2, and these are the motors which we should connect it to the driver. Yes. Okay. Next pin. You should know this diagram means that the diagram of the driver if you want to work, and then do the wiring based on that. Then first motor is connected to that based on diagram. Let us go for the next motor. Okay, next connection we will do. Just have a look. Okay, the first motor is connected. Now we should try for next one. Okay, the command feed for the Arduino Uno we will connect. And second motor, we are going to connect. Okay, then the command for the second motor is connect. Okay, we are going to put the connection for the second motor. Okay, now it's finished. Just I need the running voltage for my motor. And now we'll connect some wheel to that. Okay, right one and left one. Okay, now we should run. How we should run? First, we should specify the pins. After that, we specify some library here. Right means that left for left, right back. All of them we define as the library, and then we can run the program. Let us see what is the program that we can do here. Pin number 234. And these are the functions that now this is your task. You should write them. How it will go for the left back, right back. All of them are based on that table. Means that IN1 and IN2, which one should be high, which one should be low. And then simply you can run the motors right and left. Okay, let us see one more again simulation, but now I'm going a little bit fast to finish this because it's similar to the previous one, and it's exactly same as previous one, and you can do this. Means that the figure is like that. Just here we run one motor based on this driver. Okay, now that was the first driver that we run. Just to take little bit rest, uh, please turn on your camera, then we can do the attendance, and then we will continue for the next driver and see some more clips and some more codes, then to analyze and see what we should do. Okay, good. I think first part is okay. We can. Still, we don't have good connection. Okay. Okay. Okay, it's good for first part, I think. Let us please turn off your camera, and because I think net speed is not that much good. Please turn off. Okay, well, please turn off your camera. Let us continue. Okay, till now, what we review was regarding driver number one, but there is some problem, as you see. For that driver, it's little bit difficult to do all the wiring, and it will take lot of time. Then, if we want to have the even better controlling for our DC, for our DC motor, it's better that we use one more driver which is more powerful, and it's can have the more current supplying for our uh, DC motor. Uh, in brief, we can say this motor driver is the little current amplifier, and it takes the low current signal and give us the high current signal to our motor. And it can also control the direction of the motor. Motor drivers are of many kinds depending upon the maximum supply voltage, maximum output current, and rated power dissipation, and load voltage, and number of output. Here, this one is also is the double or dual DC motor driver, which it's more famous and people can use it. The whole diagram of this module is something like this. You can see the some current diodes that people will use. There is some regulator, input voltage, out motor number one, motor number two, and some pin which you can connect to any microcontroller. Let us see in more detail regarding this driver, which people will call it L298N, and it's using uh, the it's using to drive two motors with the voltage of 3 to 13 volt DC, and also can support 3.3 microcontrollers as the controller, means that ARM controller it can use. Nice thing is in this driver is that it can run the stepper motors, two type of stepper motors. So we will use it this week. And a little bit, if I want to give you more detail regarding this driver, it's using 5 to 35 volt, and it can have 2 ampere in total currents. Then the logic parts can have 5 to real near to 7 volts, which we just need 5 volts for the logic, for the logic part. For enabling 1.5 is okay, you can run it, and temperature can be up to 130 degree of Celsius. As you will see, this driver is more powerful than previous one, and it's more demand and lovely between the people who work with the DC driver, a small DC driver. Most of the robots are work with that small robots. I saw lots of them, lots of the engineer which work with this. You also can use it. Let us see the diagram. Diagram is very simple. You just need 9 to 12 volts voltage as input, one ground, which is common between your Arduino board and your voltage, input voltage, one signal or inputting voltage of 5 volts. That 9 to 12 volts is the voltage of the motors. Okay, 5 volts as the last one is the voltage which can run this module. You have two terminals that you can connect motor number one, motor number two at the side, and also you need enable pin in one, in two, in three, in four, same as previous one. But here you will see the number of wiring is simpler, and also little bit it's less because they put it in the form of module. Let us see how it will be the programming. First part, in if I want to run this driver, I should specify which pin is connected to motor left, which pin is connected to motor right, and then in the setup, suppose here we use the serial communication. Then we have some uh, loops I written here to just have the pin mode of them. You can even write it much more simpler. In the loop, we specify the drive forward, means that movement. We specify the function of forward, delay, motor stop. We will put the serial number one. Drive backward, delay, motor stop. We will print number two. Turn left, and some delay, motor stop, serial number three. And next function which we define, turn right, and again stop, like this. Okay, then inside of this function, what should I do? Suppose for motor stop at the next bar box, if you see here, if I put all the pin low, you know that my driver will stop. Then I use that, I make all the pin low. For the forward, I know that int 1 should be high, int 2 should be low, int 3 should high, and int 4 should low. This is forward, it can go forward. For backward, I should have the opposite things that I have in forward. Then if int 1 is high in the forward one, in the backward it should be low. And also again, um, for the int 3, it should be low if in the previous case it's high. Then turn left, it's like this, that I know that it's int 1 should be low, and int 2 should high, and int 3 should high, and int 4 should low. Then if left is defined as this, right is again opposite of this. It's very simple. As you can see this example, it can run the motors. This is the simulation in the proteus that, again, I have some clips for you to teach you how to do it for today. But let us see some practical movie also that we prepare. How to use with the help of this 298N. Uh, First of all, see the module. It's like this. These are the terminals that really you can sense them and even connect them together. The sides are the motors, these two parts. This is the VCC and ground, and these are the pins which we are going to control our driver through that. Okay, no need to do any setting or anything for that. Just we will connect the motors to this driver, and then some lithium battery or any other type of the battery, because here we wanted to use on the robots, then we use lithium battery that we are going to connect to pin number 1 and 2, and then fix it with the screw. Okay, the next pin is a 5-volt pin, which we are give it the commands. And then this is the enable pin. Just first we want to check if we give the enable, it will move or no. Just check, and we will see that okay, the driver is working like this, right one and left one. As the next part, we add the Arduino board, and we should, yes, first I will remove this because these two pin are enable pin. I'm going to connect them to my Arduino pin, a specific pin number 7, 6. The pins that can generate the PWM. I use 6, 7, 8, 7, 8, 9, and 10 pin, and also enable pin. We connect. You will see that now the number of wire is less, and you can do it much more better than previous one. Now the hardware part is okay. If I connect this, it should run. Let us see. Yes, we'll reset the Arduino and waiting for the response. Okay. Okay. As the next part, after connection, you will see that the first motor will move at right, then they are going for left. One is right, one is left, and there is some stop between them. Okay, right, left, stop, forward, back, right. If these two wheels are assembled on the one platform, you will see the movement of the robots. I'm going to give you some video regarding movement of them on the uh, platform, but you should give me some time to prepare that video also. Okay, then different speed, different thing with the help of PWM we can have. How we should do? It's again like this. Okay, now we have example number 6, which in example number 6, same driver I use, but now the speed is different. Okay. I define some demo number 1, demo number 2, demo number 3, like that. And in that, I try to make the different speed for my uh, driver. The difference between all these things is that I will generate the PWM speed on enable A and enable B. Then the speed of my motor will be different. Okay. Suppose here, as you can see in demo number 1, high and low are same, but the enable B and enable A have the different PWM speed, which if you do the programming and simulation, you will see it better here. Here also again, we change the speed, means that slowly the motors will change the PWM. Here we check the PWM job. It's not now um, much more difficult task. And you will see that in just loop section, I call the demo 1, put some delay, demo 2, and put some delay. It means I recall the function. Let us see the performance of this program. Oh, this is another thing. Okay, that program you should do and do the simulation, but I made one complicated program here that now I will not give you the code. I just give you the performance of the simulation here, that based on key and pressing the key, first we will check that which driver direction we have, and then uh, we will add the Arduino to that with the help of LCD. Here is the next one, that we are going to put the speed and direction of that. I will put the uh, proteus picture on the group. You will have these pictures, and based on that, now this is your task to write the program. I want you connect the LCD, connect the driver, connect the motors, connect the keys to Arduino board. It's semi-total nice project that you can see the speed and also do the coding. Now coding is your job, and also simulation is your job for uh, you to know that did you learn LCD, did you learn key, did you learn motors. Little bit it's review for our part of our project. This example number 7 has the good marks for the student who can do it. Okay, what we learned today is that how we should work with DC driver, how we should work and give the command with Arduino board. And the next thing is that how we should simulate them. And at the end, we had one example. I will share the PPT on MOOC. Please go and see and do the simulation part for the um, task that we will share. I wish that today you learn something new. And from this part means that from this lecture, we are going to do much more practical things as our practical sections also start. Please don't forget to give me your task on time and send it. And task number 30 is uh, doing the job. Now you have, I think now you have, you can send me task number 13. Okay, if you have question, please ask me in private on WeChat. Uh, I wish that you take care, and okay, have a good day. Take care.